So, the next topic is determination of the compaction, determination of the dry density of the soil, that is maximum dry density and optimum moisture content, that is MDD and OMC into the lab. So, there are two tests. First one test is called as the standard proctor test, second test is called as the modified proctor test. This is standard proctor test is also called as a light compaction test, and modified proctor test is called as a heavy compaction test. Okay. So, note that the both test procedure of the for carrying out this test is same, only difference is the size of the apparatus. Okay. So, what apparatus generally used for the carrying out the test is that is that so this is a standard proctor test apparatus, and this is a modified proctor test apparatus, or light compaction test, and modified proctor is heavy compaction test. Okay. So, for the standard proctor test, so this is called as a mold. This is called as a mold, and with the detachable base plate. Okay. This is the mold and the base plate. Okay. Base plate is attached to this mold. So, mold with a detachable base plate. Second one, which is called as a rammer. Second one, which is called as a rammer. So, this rammer of a weight 2.6 kg, 2.6 kg, and this rammer which is dropped at a certain height. Drop means this handle which is dropped at a certain height. The height will be 310 mm. 310 mm. Okay. And the second test, that is modified proctor test, the same apparatus is used. Okay. Only change in the dimensions and weight are there. So, this is called the mold of the modified proctor test. This is a bigger one as compared to the standard proctor test with the detachable base plate. Then this is called as a rammer, and this is the handle. So, rammer of a weight 4.89 kg, rammer of a weight 4.89 kg, and the drop means this handle which is dropped at the height 450 mm. 450 mm. Okay. And similarly it contains collar. Okay. So, this is our mold. Okay. So, this portion is mold with the detachable base plate. Okay. And at the top this top, or we can call it this top, which is called as a collar. So, this is the collar, that is which is provided at the top. This is provided at the top. So, this is the standard proctor mold, and this is the modified proctor mold. This is standard proctor rammer, this is modified proctor rammer. Okay. Standard proctor mold, modified proctor mold. Okay. So, let us discuss the first test, that is standard proctor test. Okay. So, what is our final aim? Our aim is to find out the maximum dry density, that is MDD, that is called the maximum dry density, and second parameter, that is OMC, that is optimum moisture content or optimum water content, we have to determine. Okay. So, we have to first of all find out the maximum dry density. Okay. So, this test is a similar like core cutter test, but difference is that core cutter is carried out onto the field, and this is a lab test. This is a lab test. Okay. In a core cutter test, there will be core cutter, and at the top there will be a dolly. So, here will be the mold with the detachable base plate, and at the top there will be the collar. Okay. And there in the core cutter there is a rammer, and here is also rammer of a weight 2.6 kg, because we are studying that is standard proctor test. Okay. So, what is our final target? Our final target is to find out the dry density. Okay. Dry density. So, dry density, first of all we have to find out the bulk density. First of all we have to find out the bulk density, that is bulk density, that is a mass upon volume. Okay. And then we have to find out dry density, that is rho d, that is rho upon 1 plus W is the relation between the bulk density and the dry density. So rho is the bulk density, rho d is the dry density, W is the water content. Okay. So first of all, we have to find this bulk density by using formula rho equal to mass upon volume. Okay. So while doing this test, this test is divided into two parts. First of all, first part is the preparation of the soil sample, and second part is the actual that is a compaction procedure or actual finding out the that is a bulk density. So first part, that is the preparation of the soil sample. So for preparation of the soil sample, we have taken 16 kg of the soil, 16 kg of the soil, which is passing through 20 mm ISU, which is passing from 20 mm ISU. Okay. Then in this 60 kg of the soil, we are adding certain quantity of water. So let us consider 10% of water, which is should be less than that is water estimated optimum moisture content. Okay, estimated what optimum moisture content, or we say just sprinkle the water onto the soil sample, that is 16 kg of the soil sample. Okay, then this sample is kept in an airtight container or airtight tin for 20 hours, so that all the water should be mixed into the soil. Then divide the sample into 6 equal parts. Divide the sample into the 6 equal part, because we have 60 kg. So 16 divided by 6, that is we have 60 kg of soil sample, that is 60 by 6, that is 2.66 kg. So that is approximately 2.70 kg per sample, which is of size 2.70 kg, approximately 2.70 kg. So take one part only, because we have 6 part now. We have 6 part, that is 16 kg, that 2.70, 2.70, 2.70, 2.70, 2.70. Okay. Out of this 2.70 6 part, take only one part, only one part, and finding out the bulk density. From the bulk density, find out the dry density. Okay. So first of all, take only one part of the soil sample, that is 2.70 kg of the soil sample. Okay. Then take the mould. We know the mould. This is our mould. Okay. So first of all, clean this mould, and the base, clean this mould. Similarly, this collar, mould and the collar. Okay. Then apply some grease or we can say oil inside this mould. Apply some grease or oil inside the mould. Then this mould, which is placed into the floor, which is into the floor. Then we have 2.70 kg of the soil sample. Okay. So this soil sample is filled into the mould into 3 equal layers. Okay. That is 2.70 by 3, that is 0.9 kg. So one layer is approximately 0.9 kg, then 0.9 kg, 0.9 kg. Okay, 0.9 kg, 0.9 kg, 0.9 kg. But note that while filling into this mould, suppose we have to fill first layer, that is 0.9 kg. For filling this 0.9 kg, by using this rammer, we use number of blows. We use number of blows by the rammer. The rammer which is having free fall output 310 mm. Okay. So अब हम क्या कर रहे हैं, ये जो मोल्ड है, ये मोल्ड में हम 0.9 kg का सॉइल सैंपल फिल कर रहे हैं. तो 0.9 kg का सॉइल सैंपल हमने उसमें फिल किया. फिल करने के बाद हम क्या कर रहे हैं, उसको टैंपिंग कर रहे हैं. टैंपिंग किससे? वो जो रैमर है, वो रैमर से हम क्या कर रहे हैं, टैंपिंग कर रहे हैं. ईच लेयर को हमको कितने बार टैंपिंग करना है? गिव्स 25 नंबर ऑफ ब्लोज. कितना ब्लोज देना है? 25 नंबर ऑफ ब्लोज. तो ये इसको टैंप कर रहे हैं हम ना. तो व्हाइल गिविंग टैंपिंग, we are giving 25 number of blows फॉर ईच लेयर। ओके, तो ये हमारा एक फर्स्ट लेयर फिल हो गया, ठीक है। सो फर्स्ट लेयर फिल हो गया, उसके बाद दूसरा 0.9 kg का फिल करो, उसके लिए भी 25 नंबर ऑफ ब्लोज दो, 25 नंबर ऑफ ब्लोज दो, दैट इज टैंपिंग 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 25 नंबर ऑफ ब्लोज। उसके बाद थर्ड लेयर वो फिल कर दो, उसको भी 25 नंबर ऑफ ब्लोज दो। बट नोट दैट द कॉलर शुड बी at the top of the this mold, collar should be at the top of the mold, ठीक है। आपके अब आपकी तीनों भी लेयर आप फुल्ली भर चुके हैं। अब क्या करेंगे आप, रिमूव दिस कॉलर, रिमूव दिस टॉप ऑफ द कॉलर, रिमूव दिस टॉप ऑफ द कॉलर, रिमूव द कॉलर। Okay, so this is our mold, and this is our mold with the detachable base plate. So this mold which is filled into 3 layers, 1 2 3। ओके, और उसके ऊपर क्या होगा आपका, दिस कॉलर। ओके, तो दिस 1 2 1 2 and 3। अब क्या करो, तो रिमूव दिस कॉलर, रिमूव दिस कॉलर, बाय रिमूविंग दिस कॉलर सो आवर माउथ लुक्स लाइक दैट। ओके, तो इसके ऊपर का जो सरफेस है वो क्लीन कर दो, तो क्लीन द सरफेस, क्लीन द सरफेस, ठीक है। सो नाउ take the weight of this mold, take the weight of this mold. So its weight will be weight of the mold plus soil sample, weight of the mold plus soil sample, weight of the mold plus soil sample. So let us consider its weight, say it is as M2, say it as M2, that is weight of mold with the soil sample, that is M2. Okay, so we have to find the bulk density, that is rho equal to m by phi, but m means mass of the soil sample and phi is the volume of the soil sample. Okay, so here we are getting, that is mass of the soil sample plus mold, mass of the soil sample plus mold. Okay, so we want only mass of the soil sample. So now we are deducting, that is a self weight, that is a mass of the empty mold, mass of the empty mold. So for that purpose, initially what we will do, we take initial empty weight of the mold, so say it as M1। तो हमने क्या किया, टेस्ट करने के पहले हमने क्या किया, ये जो एम्प्टी वेट है उसका एम्प्टी वेट हमने बैलेंस पे चेक कर लिया, तो उसको बोले हम M1। और M2 क्या है हमारा, M2 दैट इज वेट ऑफ माउड प्लस सॉइल सैंपल। तो हमको सॉइल सैंपल का वेट कैसे मिलेगा फिर, खाली सॉइल सैंपल का, दैट इज M2, दैट इज रो इक्वल टू M2 माइनस M1 upon V, M2 minus M1 upon V, where this M2 is weight of the soil plus mold, and M1 it is weight of empty mold, So इसमें से ये सब्सट्रैक्ट करने के बाद आपको क्या मिलेगा, ओनली वेट ऑफ द सॉइल, अब डिवाइड बाय वॉल्यूम। अब ये वॉल्यूम कैसे कैलकुलेट करोगे, so volume that can be measured by measuring the dimensions of the mold, that is measuring the height of the mold by using scale, measure the height of the mold. Similarly, measure the diameter of the mold. Once we calculate the diameter, once we measure this height, we can say h is the height of the mold, and d is the diameter of the mold. So from that we can calculate the area, that is pi by 4 into d square. We get the area of the soil sample, multiply by this height is nothing but our volume. So from that we are getting, that is the bulk density. How we are getting bulk density, that is mass upon volume, mass of the soil sample of the volume upon volume of the soil sample. Mass of the soil sample is equal to M2 minus M1 upon V. So M2, that is the weight of the mold plus soil sample minus weight of empty mold. So here we are getting mass of the soil sample only upon volume. So volume we are calculating by measuring the dimensions of the mold, that is measure the height of the mold and measure the diameter of the mold. So once we measure the diameter, calculate the area, that is pi by 4 into d square, multiply by height, we are getting the volume. So here we are getting the bulk density, that is mass upon volume. From the bulk density find out the water content, once we getting the bulk density, find out the dry density. How we measure the dry density? That is rho d equal to rho upon 1 plus w. Okay, so we know the bulk density. Okay, so for water content, for determination of water content, take the soil sample from the mold, and send it to the determination of the water content. So how we determine the water content? So we know the water content formula, that is W equal to W2 minus W3 upon W3 minus W1. So where W2 is empty weight of the container, this container. So suppose container means it is a simple container or simple pan. Okay, so we are taking initially empty weight, so it is empty weight of the container, that is W1. W2 means weight of container plus soil. तो हमने क्या किया, ये जो माउड में जो सॉइल बचा था, जो सॉइल है उसमें से उसका थोड़ा सा सॉइल लिया, तो उसको बोले हम वेट ऑफ कंटेनर प्लस वेट सॉइल, उसका वेट लिया, दैट इज वेट ऑफ कंटेनर प्लस वेट सॉइल. W3 क्या होगा, वो कंटेनर हम क्या करेंगे, ओवन में रखेंगे फॉर 24 आवर्स. फॉर 24 आवर्स वी आर कीपिंग दिस कंटेनर फॉर ओवर for 24 hours by giving the temperature 105 plus minus डिग्री सेल्सियस. ओके, उसके बाद वापस उसका 24 आवर्स के बाद उसका वेट लेंगे, दैट इज W3, दैट इज वेट ऑफ द कंटेनर प्लस ड्राई सॉइल. ड्राई सॉइल क्यों बोलेंगे उसको, क्योंकि उसमें का जो पानी है वो पानी सब का सब निकल जाएगा, दैट इज W3. फ्रॉम दैट वी आर कैलकुलेटिंग द वाटर कंटेंट बाय यूजिंग ओवन ड्राइंग मेथड. तो ये वाटर कंटेंट का वैल्यू इसमें डाल दो. आपको बल्क डेंसिटी तो पता है, हमने कैलकुलेट किया हुआ है पिछले दिन, और रो डी निकालेंगे. उसके साथ हम क्या निकालेंगे, रो डी, दैट इज ड्राई डेंसिटी. तो हमारा फाइनल टारगेट क्या है, टू फाइंड आउट द MDD, दैट इज मैक्सिमम ड्राई डेंसिटी एंड optimum moisture content or optimum water content. So we have 6 samples. हमने अब ये टेस्ट किया है, it is only for one sample. So we have 6 samples. So repeat this procedure 6 times. तो आपको 6 सैंपल है, तो 6 सैंपल के आपको ड्राई डेंसिटी आ जाएगा, वाटर कंटेंट आ जाएगा, बराबर है ना. ड्राई डेंसिटी आ जाएगा, वाटर कंटेंट आ जाएगा वो फॉर्मूला के हिसाब से. तो उसके हिसाब से प्लॉट द ग्राफ. So while plotting the graph, 6 सैंपल है आपके, तो वाटर कंटेंट को, सो ये W1, सो वाटर कंटेंट 1 2 3 4 5 6. सो एक्स एक्सिस पे हमने वाटर कंटेंट निकाला, ठीक है. वाई एक्सिस पे हमने ड्राई डेंसिटी का वैल्यू निकाला, ठीक है ना. तो ये इसका भी 1 2 3 4 5 6, ठीक है, 6 हो गए. तो इसके हिसाब से हमने क्या किया, एक कर्व ड्रॉ किया, ठीक है ना. 6 वाटर कंटेंट की वैल्यू, 6 ड्राई डेंसिटी की वैल्यू, बिकॉज वी हैव 6 सैंपल्स. फॉर 6 सैंपल 6 वाटर कंटेंट वैल्यू एंड 6 ड्राई डेंसिटी वैल्यूज. After getting all this value, we are plotting the graph. Once we plotting the graph, okay, so our graphs looks like that. So this graph or this curve, which is called as a compaction curve, so here we can call as a light compaction curve, So this curve looks like that, is it's a parabolic shape, So how we obtain, that is our value, that is target, that is MDD, and OMC, that is optimum moisture content. So for that purpose, MDD means maximum value of the dry density. So in this curve, maximum value of a dry density, which is our maximum dry density, or crest of the curve, that is the highest value on the curve of dry density which gives the maximum dry density, at the crest of the curve, that is the maximum dry density. Okay. And for finding of the optimum moisture content, we are taking perpendicular from this line. So here we are getting the optimum moisture content. So water content at this point, that is, if our water our MDD is here, that is maximum value of dry density is here, and if we plot it perpendicular to this line, we are getting the that is water content. So this water content is nothing but our optimum moisture content. So this water content is nothing but our optimum moisture content. So what is MDD? That is maximum dry density, that is maximum value of the dry density which is obtained on the compaction curve. And what is optimum moisture content or optimum water content? That is water content corresponding to the maximum dry density, water content corresponding to the maximum dry density. If we plot the perpendicular to the dry density, we are getting the value of the optimum moisture content, optimum moisture content. Okay. So this is our standard Proctor test. Okay. So this is our mold, okay. So this is our mold, this is our collar, this is a detachable base plate, these are the cans which are used for the determination of the water content, and this is called as a rammer, okay. So this rammer which is having a handle that can be lifted, at a certain height. The height will be 310 mm. Then after lifting at a certain height, leave it, so it is freely fall up to the height 310 mm. It is freely fall up to the height 310 mm. Okay. So procedure by figure. First of all, preparing the soil sample. So initially we are taking the 16 kg of soil sample, we are adding some quantity of the water, then take this soil sample for 20 hours, kept it at 20 hours, then fill this soil sample into the mold. So this is our mold. Okay, note that this is only our mold, here we are not attaching the collar to this mold. So we are filling with this mold, then so this is our collar, we are attaching the collar to this mold. So this is only mold, and this is collar. Okay. And then by the rammer we are giving the tamping. So this is our rammer, we are giving tamping. Okay. With this rammer, okay. After filling into the mold, we are filling into 3 layers by giving the 25 number of blows to the each layer. After our compaction procedure, that is total 75 number of blows are given to the this mold. Remove the collar and level the surface. We are leveling this surface. Okay. So ये surface हम यहाँ पे level कर रहे हैं, ठीक है. So here our soil sample. So this soil sample हम उसको क्या कर रहे हैं, ये जो टीन है that is container में हम डालेंगे और send it to the determination of the water content. Okay. So this is the M2. This is our M2. Note that this is our M2. That is weight of the soil sample plus mold. Because this is our M2. This is the weight of soil sample plus mold. Okay. Plus mold. Okay. So next is what is meant by the compaction curve. Okay, what is meant by the compaction curve? So we already plotted our compaction curve, that is the plot of water content which is on x axis. We are plotting the water content on x axis and dry density rho d or gamma d on y axis. This curve which is called as a compaction curve. Okay, that is because we have 6 sample. For note that this ये जो टर्म है वो आपको ऑनलाइन में पूछेंगे, व्हाट इज कॉम्पैक्शन कर्व, व्हाट इज एमडीडी, व्हाट इज ओएमसी, व्हाट इज जेडएवी. ओके, सो दीज आर द defined terms that may be asked many times in your examination. Okay, so water content we are plotting on x axis, dry density rho d or gamma d on y axis, and once you are plotting this curve, this curve is called as a compaction curve. That is a plot of water content on x axis and dry density or dry nutrient on y axis, which is called as a compaction curve. Note that compaction curve for light compaction test is called as a light compaction curve, and heavy compaction test is called as a heavy compaction curve. Heavy compaction test is nothing but our, that is a modified Proctor test.